All right, welcome back. This is Noah, and we're going to go over in this video whether a equation is a function y of x or x of y when it's given in symbolic form now. So we're going to look at some examples and talk through each one and see some strategies for determining if an equation given in symbolic form is going to be a function with x is the input and y is the output, or maybe the other way where y is the input and x is the output. So this first example, this is our only example with 6 different sub-examples inside of it. The instructions say which of the following equations constitute y being a function of x. And then we're going to check as well if x is a function of y. There we go. So the first equation we have is 2x plus 3y equals 5. And so we can try, one strategy we can have is try rearranging things. If I subtract 2x from both sides and get 3y equals negative 2x plus 5, I can divide by 3 to get y equals negative 2/3 x plus 5/3. Remember, divide the 3 by the entire right side. So here we can see if we plug in any x value and we then multiply it by negative 2/3 and then add 5/3, we're only going to get a single y value out. We can also see that this is a straight line. There's no curves to it. There's nothing strange going on. For every x value, there's going to be exactly one y value. And moreover, with this, we could have solved for x. Let's take it from the top again. If I subtract the 3y, I'll get 2x equals negative 3y plus 5. Divide by 2 and I'll get x equals negative 3/2 y plus 5/2. And so we can see that either direction, if we have a y value, there's only going to be one x value that goes along with it. If we have an x value, there's only one y value that goes along with it. So this is both ways. This y is a function of x. And x is a function of y. Right. Let's look at part B. We have y equals 1 over x cubed. Let's just think about how this is going to work. If I plug an x value in, I'm going to cube it, and then I'll just get one number out when I cube that x value. And then when I go 1 divided by that number that we got when we cubed, we're just going to get one number out of that as well. So by order of operations, we have y is a function of x. Now it's a little more difficult to tell the other direction, but if I have a y value, let's take 1 for example, we ask, is there more than one x value that would get us to that y value, right? If y is 1, is there more than one x value that would go with that, right? So if we're inputting a y value and saying, is there more than one x value? Is there more than one output for that y value? If we think about that, the only answer here is x could only be 1. If x was a negative 1 and we cubed it, it would give us a negative 1 for the y value, right? If we go negative 1 cubed, that is negative 1, and then 1 divided by a negative 1 would be a negative. So we could do that with any number. We could think of y being 1/8 or 8 or negative 8 or negative 27, or we could do decimals as well. And every time we solved for x, I'm going to do that. I'm going to solve for x in general. I'll multiply both sides by x cubed. I'll get x cubed times y equals 1. We can divide by y and get x cubed equals 1 over y. And then we can take the cube root of both sides to get that x equals the cube root of 1 over y. And so for each y value, when I take a cube root, I'm only going to get one answer out for the x. So this is x is a function of y as well. All right, if we look at part C, the similar kind of thing is going to happen. I could write this. I can see for a single x value, when I take that to the fifth, I'm only going to get one y value out. So y is a function of x. If I take the fifth to the other side and say that I have the fifth root of y equals x, right, by solving for x, just move that x to the fifth over to the other side as a fifth root, we see that if I take any y value, then I can take its fifth root and I'll only get a single x value. X is a function of y as well. All right, we're going to start getting into some where I think we're going to get some answers where they're not both functions in both directions. So let's take a look at part D here. We have y equals plus or minus the square root of x plus 4. If I plugged in if x equals 0, right? If we plug in x equals 0, then we get y equals plus or minus the square root of 4 equals plus or minus 2. So we're getting two outputs. So y is not a function of x. And then what if we try and solve for x? If I square both sides, I'd get y squared equals, I want to create some more room here so I can do this right for y'all. Sweet. Let's rewrite it. Y equals plus or minus the square root of x plus 4. So I'll square both sides. When I square a plus or minus, it makes them both positive and it kills off the square root. So we'll have y squared equals x plus 4. And then I can isolate the x by subtracting the 4 to get x equals y squared minus 4. So here, if I plug in a y, I'll square it and then subtract 4, and I'll only get a single x value out. So by order of operations, x is a function of y. If we think of y as the input, there's only going to be a single x value for each y value, even though the other way it doesn't work. All right, looking at part E, we have the absolute value of y equals x. So if, for example, x equals 1, then we could have the absolute value of plus or minus 1 equals 1. So y could equal plus or minus 1. Right? So if x is 1, we have two different y values. So y is not a function of x. But if I plug in a y value, like if I take the absolute value of negative 3, that's only going to output a single x value, positive 3. And that's true of any number that we could plug in for y. For any y value, the absolute value only gives one number. So x is a function of y. All right, so if we think of x as the input and y as the output, one input could have more than one output. If I think of y as the input and x as the output, each input would only yield a single output. And then part F is just the reverse of this. So here, if x is any number, the absolute value only yields one output. So y is a function of x. On the other hand, if y equals -1, then x can be plus or minus 1. So x is not a function of y. If y is the input, we can have more than one x value as the output. Oops. All right, so those are the examples we're going to give for this idea. These can be a bit to wrap our heads around. We're really just going for an intro here and trying to get a rudimentary understanding of how we're thinking about this. In Math 111, in college algebra, we'll go more into this and we'll look at some specific kinds of functions and looking for trying to do it backwards, where y is the input and x is the output, and how to determine that a little bit more specifically. So these are really meant to be some hopefully somewhat basic examples of looking at things in both directions. So go ahead and look at the Now You Try problems, give those a shot, see what you can't figure out for those, and then watch the next video and I'll walk through the solutions, or the answers rather, to those problems. All right, see you shortly.